So hey everybody, my name is Kevin Hoyt. I am a Principal Evangelist at Kazing, and I'm going to talk to you about IoT and WWW. I assume you all know what WWW is, but maybe a little less familiar with the IoT part. You know, it was funny, I was with the group coming in and somebody had mentioned that they'd never checked in at Yelp, right? You go to a restaurant and you say, oh, I wonder how this place is. Well, let's Yelp it, but no one ever comes to Yelp and then it's like, oh, I wonder how Yelp is. Well, this is kind of a fun little twist on checking. I still haven't checked in, so if somebody lets me know how Yelp is, that'll be great. So we're gonna start with this guy, and I'm gonna have a few questions along the way as well. How many people know what this is? Raise your hands if you know what this is. Okay, wow, about 50%. So that's interesting. Okay, so that's not the actual size. The actual size is this size. It's about a credit card. And this is called an Arduino, however you want to pronounce it, Arduino. And this is a particular model called the Uno. And it's for those of you who aren't in kind of the IoT space, I'm not going to spend a lot of time focusing on the hardware and how the hardware works specifically. Resistors, capacitors, and all that jazz. So if that's an area you're not interested in, you can think of this just as a really tiny computer. It's got a 16 megahertz processor on it, so it's screaming. So real tiny, really confined. It doesn't have an operating system or anything like that. When you write code on it, you're writing to the metal effectively, and as they say, then you're controlling all the bits and bytes as you need to. So this is an Arduino. The cool thing about the Arduino that makes it so popular for IoT, especially as a kind of a springboard to get started, is that it is open source. So all the schematics, all the firmware, all the programming mechanisms are all open source. And that's really important because before they didn't used to be. And you would buy a $2,000 programmer system for your chip from a proprietary vendor in a proprietary fashion for that specific board and that specific chip. Gone open source, boom, you can pick up one of these from all over the place, even your Radio Shack down the street for like 25 bucks. So open source impacting all parts of the world, not just software. And Arduino Uno will be our IoT springboard for the evening. So I wasn't sure if I was going to show this slide or not, but I will since there's only about 50% of the people who had known or seen an Arduino before. So this is what the code for an Arduino looks like. And it's got two main functions in there. You can, of course, write and add your own. We're going to start with a setup at the very top. And then that'll execute once at the start. And then what we're going to do from there is say, hey, go ahead and start accessing the serial port. Okay. Now, serial port in this case is going to be a USB port. Okay. It might be a COM port on a Windows machine or other types of interfaces, but almost all IoT devices, Raspberry Pi, and many others, especially in the Arduino camp, will talk over serial. It's a very common means of communication from one system to another, and we'll use that as the foundation for how we operate today. So we're going to go ahead in the setup here and say, hey, begin serial communications. And then we go down to this loop. And you'll notice off to the side, the comment says infinite loop. I think that's one of the interesting things in the general programming world and the web world. If you write a JavaScript function that's an infinite loop, that's a bad thing. In the hardware world, that's actually a good thing. That's exactly what you want. You want it to run as fast as it can, as often as it can, as much as it can. So you really actually want it to be an infinite loop. So what we have is an infinite loop, and this loop will be executed over and over as fast as the processor can handle it, given all the instructions that you may or may not have inside. Inside this particular loop, I'm going to say if serial data is available, so check the serial port, see if there's data available. And if there is, then go ahead and read it in, and then print it back out. Now those two lines are really important, and those are really the foundation for everything we'll do this evening. Serial read is reading bits and bytes across the wire that are coming from the USB port into the Arduino, okay? And we can treat that as bytes, or we can treat that as characters or integers. We can do all kinds of manipulations to it on the incoming side. In this case, I'm going to read it. Its actual data type as defined by the function is actually an int. So we'll pull in an integer. And then the next one is to print it. And that's sending data back out from the Arduino over the serial port. In this case, we're going to map it from an integer to a character. So we actually see character data coming back across the wire. And those are the two in and out via serial. Let's see that in action. real quick. I'll plug this into the USB port. And which way do I want to go here? My desktop's always a mess when I build presentations. I start putting assets everywhere. So I'll go ahead and open this, which is exactly what you saw on the screen earlier. I know it's small now. And then I'll go ahead and what I'm going to do is tell it that it's going to an Uno board. As you can see, there are lots of different Arduino prototype, different types of boards. I also want to tell it what port it's on. The 21 is the one on the other side of my Mac in this case, so it knows how to communicate to it. And then I'll go ahead and click this button to send it to the board, and the board kind of lights up a little bit. It may be hard to see in the back. From a UI perspective, it says, hey, we're uploading. What happens is it actually compiles the C down to instructions for the chip itself. And then when I open up this little serial monitor, and this is really the interesting part from an IoT perspective when we talk about getting things on the web, open up the serial monitor here, and that lets me communicate to the Arduino over the serial port. And it turns out the Arduino IDE is written in Java. Many languages can communicate over the serial port. In this case, if I type in hello, if you remember the code, it's going to loop through the serial data as long as it's available and send it back to the send it back to the port. So we'll say hello, and that hello has gone off to the board. The board's read the bytes and send the bytes back, and so what you see is hello back in the serial monitor. So that's gone all the way around trip from the IDE and our user interface here through the cable into the chip, back out the chip, and then back to your screen. Okay, so that's how the functionality is basically going to work when we start dealing with this stuff. Cool. Serial. like Cocoa Pops or something. All right, so obviously if we're going to talk about IoT, Internet of Things, we need a thing to talk about. So I made one. I'm going to call it the SF-HTML5 thing. So this is our SF-HTML5 thing. It'll be on a failed Kickstarter near you soon. Not really. This is a basic schematic of, or a high-level kind of wiring schematic of how it actually is plugged in. Just because it's very difficult to see in my hands, but this is the size of it in my hand. On the map there's two main parts that we're interested in. One is an LED. And for those of you, how many people here kind of know their way around electronics pretty well? Okay. So you may notice that there's more here than just an LED. We'll talk about that in a little bit. Let's leave that as a little secret for everybody for now, okay? So we have an LED. You should know what an LED does. You probably have them all over the place. You probably have them in the projector, right? You see them everywhere. They light up, okay? Great. Over here is a photocell, and a photocell is a light sensor. So you can think of this as, and this is actually, it's kind of amazing what it is actually. It's a little piece of silicon, just a little sliver of it. And there's one wire coming into it, and then it hooks onto the silicon, and then through the silicon, and then back out. And silicon has an interesting property. It turns out that light, as it is exposed to silicon, will actually excite the electrons in the silicon, making it easier for light to pass through it, or for the electricity to pass through it. The less light, the more resistant the electrons in the silicon become, and so electricity flows through it less. It's kind of interesting. So it's effectively just a light sensor made of silicon, same type of silicon you would find in your chips and your boards, inside your computers, and many, many, many other places. So this is our SF-HTML5 thing. And I'm going to strap it onto the computer here. My poor little pins are getting all bent out of shape. Here we go. Oh. Fail one pin. I have an Arduino that is, in this case, the ports on it are really stiff. So as I've been yanking this in and out, practicing this presentation, the pins have become more and more warped. But nonetheless, we're plugged in. Fantastic. So now we have our SF-HTML5 thing available on Kickstarter near you soon. And we will go ahead and then we want to program it with some code. I'm not going to crawl the code like I did with the earlier example. Now that you kind of have a basic idea of the serial in and the serial out. But I will show you the basic control in that Arduino serial monitor. So let's just go ahead and put our cool deployment code on there. I go back and And there's a bunch of kind of bonus code. I love Easter eggs in my presentations, so there's a bunch of bonus code in here. It's also why I'm not going to cover it. But I'm going to go ahead and upload that to the board now. Yay, uploading to the board. Fantastic. So I open up the serial monitor. And let me go ahead and zoom in here a little bit. So you can see these integers coming across, 780s it looks like. That's actually the reading from the light sensor, from the photocell. So as I take this and I cover it up, you'll see the number drop down. In this case, it looks about 100 or so. As I take my hand off of the light sensor, it'll come back up. I'm pointing at the lights, or pointing at my screen. This Mac screen tends to be pretty bright. So it's actually showing you the data across the serial port relative to this photocell. Now this photocell will range anywhere from 0 to 1100 in value, and that's just because of the resistors I put in there and the cool Ohm's law stuff, which we won't get into today. That lets me kind of control the value range. In this case, I also want to be able to control the onboard LED because we want to send data, we want to get data in, but we also want to be able to send data out. I want to show you both directions. So I'll go ahead and just say 1, and if you guys know Booleans, you know what that does. It turns on the LED, okay? So it's true state, and it's on, yay. And then if we go ahead and put 0, send, and it turns the LED off, okay? Yay, so there we go. So we're controlling the Arduino, or our SFHTML5 thing from this Java program on our computer over the serial port, effectively the USB port, okay? All is well. Now, as I mentioned, this is Java. There are lots of programs that, or lots of programming languages that can talk to the serial port. Some are better at it than others. But one, I think, probably at this group that might be commonly used, or at least you've heard of it before, would be Node.js. How many people are ever using Node.js today? Okay. How many people have heard of Node.js? Okay. So we're going to go ahead and use, so effectively for those who haven't, right, Node.js, JavaScript on the server, if you will, at a high level. And it turns out that there's actually a module for Node that lets me talk to the serial port. Cool. So just to give you an idea of what this looks like, we're going to create a serial variable, and this, keep in mind this is in Node, okay, so we're running on kind of effectively on the server at this point. We're going to create a new serial variable, and we're going to point at the Arduino port. Remember when I had to set the type of the board and the port of the board very early on when I first sent that example to the board? And I said that this is my serial port label over here, this is my serial port label over here. It might be like a COM3 or a COM1 or whatever on a different type of computer, right? So this is telling it where to find the Arduino, and then we're telling it what parser to use as the data comes across, because keep in mind, again, it could be bits and bytes, it could be integers, it could be whatever. In this case, I like to use the new line character as a kind of delineator, so we'll use that actually going in and out, but it's going to look for new lines and call that a chunk of data has arrived, okay? And as data arrives, it's going to go ahead and fire a data function. And so we get this data, in this case, we're just going to log it out, and there's our data coming in, okay? And then going the other way, when we want to send something, there's a command called serial write, and then we can put whatever we want on there. There's actually different signatures for serial.write. You can send it bits and bytes, but in this case, we're going to send it integers, and we're going to go ahead and send that across the wire. So here in my terminal, we'll go ahead and fire that up. So now this is Node. This is no longer that Java serial monitor. This is Node accessing the serial port. And you can see the light values here, 830, 820, 830, 819, 830. So it's actually going up and down. The reason it's going up and down is because the LED is going on, going off, going on, going off. And that's the Node. Actually, every 1 second, there's a little interval set. Every 1 second, it does that serial.write and sends a byte to the Arduino saying, hey, turn on or turn off. And in fact, that's what's actually happening, is it turns on and off. And if we cover up the photocell, you'll see the light values drop down. Now they're in the 300s. And it is actually sensitive to the light itself. So if I cover it up, right now it's 2, and then the light comes on, it's like 6, almost 700, 2, almost 6, 700. So it's actually catching the light off, echoing off my hand in that case. So there's Node working with the serial port. Now, we've come pretty far away. We've got our SF HTML5 thing. So it happens to be an Arduino. We've programmed the Arduino, and now it's communicating to Node over serial port. Once we're in Node, it seems like it's not too far to get into the web, right? I mean, we're kind of working with web technology at that point, and that's actually the case. We could drop in something like Express. Express, for those of you who are not familiar with Node, is effectively just a kind of a web server plugin, if you will, for Node, and lets you route requests in different ways. So in this case, I'm going to drop in Express, and then I'm going to go ahead and route a couple different things. Now, in terms of, you have to think of the Arduino in this case as a chunk of data somewhere, almost like you're going to try to query a database, right? If you're going to go and say, hey, get the first 10 employee records, right, from your web page, you would, in many cases today with like a single page application architecture, you might use XHR, or if you're using a jQuery, you might use like the JSON or the AJAX call, or other types of libraries have calls effectively to let you do that data communication in the background. And when we communicate to that data in the background, generally speaking, we're going to use a REST format. It might be other formats depending on your architecture. I'm going to use REST just to kind of make it kind of more standards based, if you will. We're going to use a get call now, and well, I'll come back to that. We're going to use a get call here, and we're going to say, hey, get, if it's get/photocell, so if it's a get request, HTTP get request for /photocell, then go ahead and respond to that request with the JSON encoding of the light value from that photocell. You'll notice that light is declared. There's a bunch of code obviously I've left off. Light is one of those variables which we'll come back to. And I even made a comment of it. What is the light variable? So we'll come back to that in a second. Just to kind of drop some kind of what I call pro tips along the way. So the other one we're going to do here is, and this, I think if you're going to do true REST, this would probably be a put, because what I'm doing is functionally is changing the value of something that already exists. Post would also work. In this case, I've just strapped a get in here to make it simple. And also because Express 4 and body parser. Hello, if anybody's, anyway. So I'm going to go ahead and use a get. I'm going to say if it's a get request for /LED /something, whatever that something is, let's go ahead and parameterize that as a variable and use it in our code. In this case, it's serial.write, whatever parameter is coming across as that state. So if I send a request either /0, it'll serial write 0 across over to the Arduino, which we saw earlier, we did 0 and it turned off. If I send a URL, put my URL a /LED/1, it'll come in here, it'll send that 1 across the wire, the Arduino will turn on its LED, okay? Let's go ahead and see that in action, and then I'll show you. No, let's talk a little bit about that. So I mentioned that light variable that we talked about earlier, right? If we get the photocell response JSON light. So it turns out light is an array. Not incredibly amazing. The problem here is that you have to think about how the data is coming in. The photocell on our Internet of Things, whatever, isn't waiting for an HTTP request. It's constantly trying to send that data across the serial port. It's not waiting for you. It doesn't know when you're going to be there. So effectively what we need to do is we need to kind of decouple the incoming data from the actual HTTP work that's going on, okay? So what we're going to do is we're going to establish an array, and then as data comes in from the serial port, we're going to go ahead and push onto that array whatever the latest integer coming off the light cell is. That's going to happen completely separate as the data comes in from the sensor. And so that's what we're going to do separately. And then at some point in the future, right, somebody's going to make an HTTP GET request for /photocell, and we're going to JSON out that array and send whatever values have been coming in off to the client. So two separate, if you will, separate threads, separate processes, separate functionality going on here. And that's very important because you don't want to bottleneck either or. And you can actually it actually can bottleneck. This might seem like a bottleneck from the the browser waiting it, but you can also bottleneck it at the hardware side, and hopefully we'll see that in action here in a little bit as well. So, so what does this look like? Well, let's check it out. I'm going to drop back into Node here, and I have added those parameters on, and then I have a web page to accompany that. So we just go localhost here. Now, right now, you're killing me. It has hit a breakpoint. When did that get set? There we go. So you can see as I move my hand over the photocell, the chart on the bottom represents the photocell intensity, right? And it goes off, it drops off the edge. As I move my hand away, it comes back up, okay? So keep in mind, this isn't waiting for these requests. This is pumping out data to Node all the time, totally separate. And that's a very key thing when you get into the IoT world. And then the other thing I have is that HTML5, which in this case, if I click on it, it's going to use a little CSS animation to turn the logo. But also the LED comes on. It's going to make a GET request in to the node. The node's going to pass that parameter on. I'll take my mouse off. It goes away, okay? So if I cover it up, we'll see a change in the chart. I push my mouse, you'll see it spike up, pick it off, right? You can actually see how the data is being recorded, okay? Pretty cool. So just a really quick look at the code here. Yeah. So what I have going on is an interval to go ahead and query the server in this case, I set it up for once a second. When you think about the IoT, think about all the customers you have and the current load that produces on your infrastructure. Imagine now every one of those customers having a dozen different devices on them. Right? Now you suddenly have a big scale problem. And that's one of the things that IoT can very much kind of cause havoc with your infrastructure. So in this case, what I'm going to do is set up a query to happen once every second, which in a production world is probably a bit heavier the load than I want to put on my server, but we'll go ahead and go with 1 second. And then every 1 second, it's going to go ahead and make a request. It's going to make a GET request. This is just straight up XHR. It's going to make a GET request for the photocell URL I mentioned. It's the /photocell. And it will go ahead and then come back. And we'll go ahead and store up that data into an array here. And then we'll go ahead and redraw the chart once a second. So that's actually what's going on the client side. And the logo up and down is not a whole lot different. Effectively, when the logo, for example, in this case, when I click off the logo, take my finger off the logo, make an XHR request for that /LED/0, it goes off to Node. Node passes the zero along to the Arduino. The Arduino turns the LED off. And eventually we get a response. In this case, I just discard that response. So there is the code that makes that HTTP-based approach work. Very fun. So I mentioned decoupling. That's one of my pro tips. If you're going to get into IoT and connecting it to the web, decouple the two is one big thing. And keep in mind that the data coming off of that chip can be coming at it very fast. So you have to make sure that your infrastructure is going to scale to support not only the customers that are trying to access their data, but also the incoming data from the device itself. The other thing that I like to emphasize when it comes to IoT is SVG. I'm generally, just in general, a big SVG fan. I think it's one of those technologies that kind of gets not enough play, especially when you talk about responsive design. SVG scales beautifully. It's supported very well across many, many browsers. It gives you all kinds of really fine control, very crisp images, very crisp, in this case, charting and rendering. So I encourage you to use SVG, at least become familiar with it if you're not. In this case, I've actually, for me, I'm not a frameworky kind of guy. I like to go kind of straight to the source. So I use the DOM to manipulate the SVG directly. I found that in my case, many libraries that kind of wrap some of the SVG sophistications, many of those libraries are, they bottleneck what things you can do. So I tend to just go straight to the SVG. SVG is not particularly intimidating. It doesn't have to be. This is the chart, effectively. I have a linear gradient for the fill that you saw there at the bottom. This is in a defs, essentially reusable chunks of code that I can refer to over and over. And then I have a G, which is a graphic. You can have multiples of graphics in there. And then a path. I have two paths, one for the edge of the chart and one for the actual fill. Because I don't want to have a stroke on all four sides. So I draw the chart once with just the top, and then I draw it again with the fill. And because it's SVG, it renders very quickly, it renders responsively, and it's just a great technology. I encourage you to use it when it comes to charting and working with data visualization in general, but especially when it comes to IoT, just because it's so fast. WebSocket seems like a good next step, right? I mean, seeing data once a second, I guess, is okay. It's kind of chunky, though. I mean, it was kind of like, hey, well, that's kind of, I want to see the data. I don't want to be in this world of wait and see. I want to see the data now. So WebSocket gives us a web standards-based approach to access that same functionality as it comes from the chip in real time. And WebSocket actually starts initially as an HTTP. If you're not familiar with WebSocket, how many people here have used WebSocket before? Okay. So if you haven't used WebSocket before, effectively it starts out life as an HTTP request and then gets upgraded along the way and becomes effectively just a socket. And at that point, you can send whatever bits and bytes across that you want. So that's effectively what we're doing here. We're just going to say, hey, and this is our node code again. We're going to, hey, HTTP create server, which is just creating a server for us to use, a basic web server, because we have to have that incoming HTTP request to get upgraded. So this is a basic web server. And then we have a create WebSocket server, so we'll put the WebSocket server on top of that server so that it can handle and route requests. So that's how it sets up. And then to actually handle the requests themselves, we want to keep track of the clients, because keep in mind, this isn't a fire and forget situation. This is a I know who you are situation, and I can send data to you when I want to. And you can send data to me when you want to. And we know about each other, and that's all great. So we have to keep track of who's connected. And then when we have a request come in, we're going to go ahead and accept that, and then we're going to add a listener for any messages that are coming from that client. Okay, messages is kind of an interesting new term for us, perhaps. It's a piece of data coming across the wire to us at the server. Then conversely, if we want to send data back out, we might want to send it out to specific clients, and we can keep track of who those are and what they're, how to identify them through our array. But here I'm going to actually just say, so as a snippet on the bottom, I say clients C, so it's an array element, right? I'm going to be able to send out to multiple clients some piece of data. So that's how to set up the WebSocket server, and then how to actually go ahead and get data and send data from a client. Okay, back here. So we'll stop out of the world of HTTP and REST. In this case, we'll go to HTTP and upgrade it to a WebSocket. And before I show you the chart, I'm going to modify my code a little bit. I'm going to take off the REST-based approach. All right, so off comes REST, and on comes WebSocket, okay? And what does WebSocket do? So this is JavaScript on the client then. You may or may not need to polyfill depending on the browsers. WebSocket tends to be somewhat new. In this case, we're going to go ahead and I'm just going to check for the Mozilla WebSocket and just for WebSocket. And then we're going to go ahead and establish a new WebSocket, and then we're going to go ahead and add listeners for when the connection is opened, if there's any messages that come in, and when there's any errors. When messages come in, so socket message, we're going to go ahead and get an array of the data points. As they come in, we're going to fill up, we're going to populate that data into the array. And then we're going to go ahead and, in this case, I don't want to display everything that comes off of it. That would be a whole lot of data over time. So I'm just going to chunk it down to 100 data points. And we're going to go ahead and graph that. So that's what WebSockets looks like from the client side. Let's see, make sure I saved all this here. Let's see what that looks like in action now. So now we're moving along a little bit faster. Certainly not the chunk. It's moving right along. And to show you that it is responsive, if I take it and go ahead and cover it up, right, it goes down and it goes up. And if I click on the logo, right, we get the up and down. Yay. All right, so now it's moving a bit faster. But you might say, well, that's not, I mean, it's better, but it's not awesome. I mean, it's kind of faster, I guess. So I would love to say, oh, the chip is, you know, it's a little 16 megahertz processor. What do you expect? But actually, that's not the case. As it turns out, I've just throttled the chip intentionally. In that chunk of code that I put on here originally, I said there was a bunch of Easter eggs. This is one of those Easter eggs. I have a little piece of code in here that's intentionally throttled the chip. I'm going to go ahead and send a command to the chip, tell it to unthrottle itself, and we'll see a whole totally different experience. How's that for responsive? Right? You can actually see how the electricity hits the LED and leaves the LED as we hit that. Right? That's just a 16 megahertz processor. Okay? Going over WebSocket real time. I toggled it back off, now it's going slow again. So that's the delta between a REST-based approach and a real-time with WebSocket approach. You had a question?
So you could open up 2 windows and get 2 traces?
I don't know. Let's try.
The world could open.
I'm actually going to take it there in a little bit, but I want to. I'm curious actually now if that would work. It should. The question, yes, the question is, can I have 2 windows and see the data as well? So I'll go ahead and that, and so now we can, yes, so now we have both windows all seeing the data. Yeah, buddy. That's pretty cool.
So how often do you pull data from the serial port now?
Good question, yes. The question of how often do I pull the serial port data? I don't. I take it as fast as it comes. So I don't actually have to pull it. I take it as fast as it comes. And in this case, Node, I'm not really interested in storing our, I mean, I'm not going to actually launch this Kickstarter, right? So I'm just going to have Node just dump off the data and drop it off into nowhere land. I don't really care. Normally, if a real IoT device, you would stick it in a database, right? Ideally, something that's scaled very well. Because I'm sorry, I don't understand the question. The only event that happens, so the questions are on the events that happen. The only event that happens here is the serial port part in Node knows that it got some chunk of data. In this case, we saw that new line delineated earlier. So I'm choosing to send the chunks of data as it gets a new line. It could be just a byte. It could be any different number of different things. In this case, I've chosen a chunk of data terminated with a new line. That happens on the serial port data. And as it gets that, it sends it off to wherever. Streaming, exactly. And ideally, you probably want a streaming solution for your database as well, right? You can send this data in, look for certain flags in your data as it's coming in, as fast as it's coming in, and then be able to raise certain flags off onto the client, tell them, hey, you know, Joe Smo has a fraud detection, and we're going to go ahead and trigger that out, and so other things like that. So, yeah, the IoT kind of, when you go with IoT, it kind of creates a shift in mentality. And that's why I titled this talk, When IoT Meets WWW, because I think IoT is coming, and we see it today in kind of a nascent form, really, like a Fitbit, like a pedometer, those over various pedometer devices. Those aren't really, in my opinion, they're not really IoT devices. They're really just batch collectors of data. I might as well be a USB stick you're plugging in, frankly, and then you're just sucking the data off of it. That's not, I mean, it's kind of internet connected because you can see your data in the internet, but something like this is real-time internet connected data. This is totally different level. We'll talk a little bit more about this in a little bit. So yeah, so there is WebSocket. That was the surprise, my Easter egg. Gotta have a cat in your presentation. It's a requirement. So So today, we have our SF HTML meetup thing, and it's connected via USB port to my computer. So it's not really very internet-y. It's more like laptop-y. So we want to get rid of this wire. As any decent web developer might normally do, when they see a nail and they have a hammer, or they have a hammer, everything looks like a nail. So in this case, you might say, well, what I need to do is move that node stack onto the computer. I need to ship it along with it. Again, in this case, it doesn't have an operating system. So you're not gonna, it's not like you're going to put Node on here per se and manage a couple modules for serial port access and then another couple modules for WebSocket access and probably more modules for for Wi-Fi access, and then of course Express module. That becomes really tedious. And this is where most web developers will go initially. Something like this is a Raspberry Pi. This is actually the B+, the new one. And I'm a big fan of Raspberry Pi. I'm not trying to knock it. I use it in a couple different projects myself. But the Raspberry Pi has an operating system. It's a Linux-based operating system. You can put Node on it. You can put all those different packages on it. You can connect a little USB Wi-Fi dongle in there. Good to go. You're connected to the web, or if you prefer, Ethernet jack. I prefer wireless myself. Right. So you have functionally a little computer that you could put Node on, and you could have a disk, and it could be wireless, and that would be great. And that's certainly a good step forward. But think about this outside of the hobbyist realm, outside of the project that you want to achieve, and think about it on a corporate kind of more global scale, something like a GE or a Ford or something like that, someone who's trying to produce this stuff for masses and masses. Right? Do you want to ship an IoT device that you're going to have to maintain the OS, the Node.js, the several different modules that you're going to need to put on it? And you're going to do that for 12 million, 50 million, how many ever millions of devices end up being deployed across the globe? Like that becomes a real nightmare. It becomes a real headache. So this is a novel approach, but difficult to maintain at scale. So good for hobbyists, great way to prove out your idea. Take it to a venture capitalist and market it, whatever the case may be. Kickstart it even perhaps. But most cases, you're going to go to something a little bit more sophisticated down the road. These are some of my favorite projects for getting kind of rid of the wire. Electric Imp, little tiny, I wish I brought one this week. I didn't bring one with me. But each of these are effectively little wireless boards, and they don't really have an OS on them per se. And so there is no node. These are just ways to give hardware an IP address. That's it. And that's really ideal. Because then I don't have to worry about pushing a whole lot of code to all these guys. And in fact, many of these guys actually have means for me to push and update code and maintain versions of code and things like that on those devices. And that's really helpful. So these are going to take my hardware and give it an IP address. Awesome, kind of. The problem with these chips as they sit today is they approach it kind of the same way that we as web developers approach things, and that we all go with REST. Right, when you think about your APIs that you're accessing today, REST. Of course, you're going to make a request to something on the server, and it's going to send a response, and that's that. That's how we do things. That's how we roll. But we saw earlier what REST looks like, and what the difference between a REST display is and what a real-time display is. It's worlds apart. We were seeing the wave of data versus chunked data. Okay? So these are really great jumping off boards. If you want to look at any of those products, I highly recommend them. I'm familiar with all of them if you have any questions about any of them. But all their APIs are REST-based. And chances are at work, at your corporate environments, your APIs are REST-based. Why? Something to think about. We'll come back to that. So this is my little Jack Handy bit. I make lots of really weird references, but this is kind of what, to me, REST has become. Right? It's like an animal that's bored a hole in my head and has laid eggs in my brains, so that when I think I have a good idea and I'm going to go ahead and apply REST, it's not really a good idea. It's just those eggs hatching. REST is good, but WebSocket is here. There are fallback mechanisms. We can very robustly move forward into a real-time environment. And we should, and I'll talk a little bit more about why that is in a little bit. How might you do that? Well, so you have to, one of the best, probably the best way is to decouple things. I've talked about decoupling already from a server perspective, right? As the data comes in, decoupling it from the display, right? Another way to do it is to decouple it at the client. And I'll show you an example of that. And so in this case, what we can do is we can decouple the data coming from the client. So if this guy might be the Arduino or other hardware that we might end up going with. And it's going to go ahead and send some chunk of data over the wire to this topic in space, this piece of software in the cloud. And that piece of software in the cloud is going to go ahead and manage delivering that to any of the interested parties. In this case, maybe multiple browsers. Additionally, the browsers can say, hey, turn on my IoT thing so it can send data to that topic in the cloud as well. And then that message can travel back off to the hardware, and the hardware can go ahead and do what it needs to do. So this is a publish and subscribe model. It's REST on one hand and a publish and subscribe model on the other. And so you could put what we call a message broker. You can put that in the center, and you can have all these different pieces connected to that message broker, and go ahead and deliver messages back and forth. It's a state. We can maintain that connection and send that data at very low latency and very real time. And now we have a world where everything is very loosely decoupled. This might be a web browser, and this might be our database, or some sort of streaming analytics that sits in between us. Right? So they're all decoupled. None of them are really aware of each other. It makes it very easy to maintain them, and they can all catch that data in real time. We'll keep kind of harping on this real time, but I'll move forward with some of the technical stuff now. So this is an Arduino Yun. Yun means, I believe it means cloud, I believe is what the translation is. This is really cool. This little piece of silver here is a Linux system on a chip. And that's really powerful. It lets us do all kinds of really cool stuff. The Yun is an Arduino. It's the exact same footprint as the one we've been using already, but it actually has Wi-Fi built on board as well. So that's pretty cool. It also has Ethernet built in, and it also has the Arduino chip. So we don't have to use that Linux board if we don't want to. If we want to, we can. But we don't have to. We can actually program directly to the Arduino, tell the Arduino to send bits and bytes over the client, across the internet via Ethernet or via wireless, and then go ahead and handle that data real time over the wireless. That data is going to flow off of the wireless into the message broker. So it's going to publish content. And then that broker is going to send out messages. It's going to publish the content out to anybody who's subscribed and interested in that content. It might be your database, might be your browser, might be any other number of devices. And that's where the IoT really gets exciting, is what if this device is talking to another device in real time, right? That's still yet to come, but so I have a little magic device here with a Yun built into it. And live demos with wireless are always a gamble. So we'll see what happens here. Sweet, it's working. So, URL, you're welcome to go there. I'll go there. Doesn't look like anybody's going there. Oh, there's one. So, someone, somewhere in this room, is selecting one of the squares and changing the color. In a publish and subscribe world, in a real-time world, that's now happening on my screen. It's happening on everybody else's screen who's looking at that. And because our Internet of Things thing is listening, it's also happening here. Yeah. So that's real-time, decoupled via publish and subscribe. Yeah?
So real-time communication is pretty awesome if you're using WebSockets, but then you would assume that data is transmitted over HTTP, correct? So what if your device is using like a quote-unquote more modern protocol like CoWAP, Constrained Application Protocol? You would not have access to these real-time capabilities, would you?
As I understand it, CoApp is predominantly targeted at a peer-to-peer environment. Yeah. And that's certainly one of the means of real-time communication. There's no reason, the way CoApp is designed, there's no reason it couldn't end up in a web page. Because WebSocket is initially an HTTP request, but it gets upgraded just to its TCP socket, right? So you can certainly use other protocols over that. In fact, functionally, you could have an SSH client or right, whatever other type of client you wanted to have. Once you have that socket, it's a socket and you're good to go. And then you get into kind of the fine grains about UDP and TCP and other kinds of problematic discussions, but that's a little beyond the depth for this particular conversation. I think CoApp, though, is certainly a viable addition to the space. Yeah, and I think when it comes to IoT in general, I think it's still very new, right? So it's still, the standards are still maturing. Who's doing what is still maturing. Even in the protocols themselves, there's MQTT and various other different ways to do it. So in this case, I'm using JSON, I'm not using anything, right? Which is probably a bad idea in the long run. If I'm going to deploy, maybe not. So there are a lot of different kind of questions that come in once you get further down the chain. The point for this, though, is that we are doing real time. We can do real time, and then we can do real time in the web, and we can do that today. Okay. So is it still staying up?
Oh, yeah.
Not bad for a 16 megahertz processor. Sweet. All right. So yes.
Related to that question, does the speed of the device that you're connecting with affect the performance of the overall application?
Good question. Does the speed of the device impact the performance of the overall application? The way we've decoupled it, the answer here is no. Now, that's because this guy, again, that's why that decoupling that I talked about is so important. The device could be really fast or really slow. It's just publishing data or receiving data in this case. Subscribe to a certain piece of data and it's listening for that data to come in. The browser is working entirely independent of that. It is also listening for data. How fast one or the other goes, they don't care. They're completely decoupled.
Okay, thank you.
So, real time, and that's something we can do, and we can scale it very well by going to a publish and subscribe model. All right. Oh, sweet. So, I wouldn't be I got more demos, and I got like 10 more minutes. Yeah, we can do this. All right, so I've got several more demos because I wanted to show different ways of analyzing and receiving this data. I'm going to do. Let's see if I can get this to work. This is one of those pieces where I was like, I'm not sure if I can get wireless to work, and I kind of hustled last minute to make something else work. So I'm going to use. This is a little board I'm going to strap onto my Arduino here. I'm going to take our SF-HTML5 meetup thing off of the Arduino. And I'm going to strap on a few more parts and pieces. This is a little board that's a heart rate monitor. Not a heart rate monitor like a blood pressure cuff, not like that kind of heart rate monitor, but a heart rate monitor like you would get in, let me make sure I'm putting the right pins in place here. Like the type of, if you go running, you wear maybe a heart rate band, right? Something like that, or maybe like on your wrist or something along those lines. So that's what this is going to actually pick up is a heart rate monitor. You say, well, where's the heart rate monitor? I give you a guess where the heart rate monitor is at. It's on. I have raw on. That's right. So it's actually on me, and it's broadcast. It's just a straight up polar, off the shelf heart rate monitor. And so we'll check the serial monitor. Sweet. There's my data. All right. So now I'll go ahead and start my nodes. I was going to listen to that. And a little high right now. Huh. All right. So now let's go /HRMI, heart rate monitor. All right. I got to work on my rendering there, but I don't feel kind of.
Hold your breath.
Give him a center
Hold your breath.
Oh, I'm dead! Thanks, Peter.
Killed him.
Peter killed me. So as it turns out, I actually have that same chunk of code. What happens is I went out of range, right? That's why they have it on your wrist. I went over here, and I went out of range. That's what happened to it. That being said, I'm glad that's reported in real time. If I was dead, I want my doctor to call me. I wanted something to happen right then. I don't want to wait for the screen to refresh and then get a recall. Oh, hey, look, looks like Kevin's dead. We should send somebody to get him.
So when you said you're out of range, is this like using Bluetooth or something?
Yeah, the most of the common heart rate monitors today, like an ANT or I don't know exactly what Polaris protocol is, but the signal that they transmit is only good for a few feet. It's a basic RF exchange. I didn't see where the question from. I'm sorry, but so it's a really short, very weak, very basic RF exchange.
Yeah, the follow-up question, or the question I actually wanted to ask was Bluetooth. So for a little self-contained, I want to improve my performance in some sports activity,
Yeah.
and I'm not concerned about the internet or anything. I can gather some data about it when I want stuff in real time.
Yeah.
Bluetooth. Then
Absolutely, Bluetooth LE especially, right? Yeah. Bluetooth has been used in heart rate monitors as well for a while. LE more so now, just because there isn't a whole lot of room for batteries on these things. And a little coin cell will run these guys for a while on BTLE. That's actually what I have here. This is another telemetry sensor. If you go back at our table, at the Kazing table, and you look at our aviation-based telemetry, I use Bluetooth as a scaled down version. So yeah, Bluetooth is certainly a viable way to go as well. Bluetooth LE especially. I'm going to try one more trick here before I kind of start closing up.
So is the Express still running on your laptop or is it on the board?
In this case, it's running on the laptop. Express. The question is where is Express running? Express and the serial port is all running on my laptop in this case. I have the code for a pub sub environment for an Arduino Uno with the heart rate monitor. Unfortunately, it's very difficult to get consistent wireless when we're all in the room. So I kind of backdoor that through the serial port in this case.
And the board you suggested,
The Uno, Y-U-N, yeah.
so that's up, it's ready to buy? Or is it
Yeah, the Arduino Uno is on the market today. And I like it. One of the things the Raspberry Pi does is because it's all software based, it sometimes prevents you from getting access to the hardware. If you want to send certain pulse width modulation controls or certain very high frequency controls to the hardware that a lot of hardware today will expect, it's very difficult to do that with a Raspberry Pi because you have to go through the software first to get to the hardware. And that means if you're shooting for microsecond delays in communicating with a lot of these hardware pieces, that's just not going to happen. The software is going to get in the way. So I like the Uno over the Raspberry Pi for a lot of my real-time projects because I get access straight to the hardware. I write on the metal and I can control the bits and bytes at a microsecond interval off to the picosecond in many cases, actually off to the chip or the ports. Yes.
I have two questions. The first, what's your experience, what's your opinion of the Wi-Fi shields? And the other question, I guess, is what's the best setup if you're interested in manufacturing down the road?
Both good questions. So the first question is my opinion on the Wi-Fi shield. So Arduino, before the Uno came out, there was a number of different Wi-Fi shields that you could put on. If someone took a wireless chip, put it on the board, mounted it to the Arduino, voila. And there are a few good flavors out there. Some of the lesser innovative ones have kind of dropped off since their introduction. But in general, they're nice. They're really, especially from a hobbyist or prototyping perspective, they're really nice. The challenge you're going to face from using a Wi-Fi shield is that it's expecting you to write to that chip. It's expecting the bits and the bytes to send. Not only like there isn't a high level oh, connect to this SSID, right? Well, on this chip, it uses this AT command or this, this byte in this certain order to turn on the fact that you want to actually send it an SSID. And then you send it the SSID, and then you send it some other commands. You have to know all that stuff and get really deep into the chip. And there have been libraries that have been built on top of those Wi-Fi shields to make that easier. But that's still, I would much rather have a solid Wi-Fi stack built by a professional house when I'm going to go production. So Wi-Fi shields are good for prototyping and hobbyists, but they're not really good for scale. And then your next question then was, how do you go to production? And in a real-time environment, unfortunately, I haven't found any chips that I'm really liking that do real-time Wi-Fi. My personal favorite chip right now is the Electric Imp. They are geared up for production. It makes it very easy. They have a great support team. It makes it very easy to go from idea to connected to go. One of the challenges that you face when you go to IoT, so if this is our SFHTML device, and we're going to ship this out on Kickstarter, how do you set the SSID? Where's your display? Where's your keyboard? Mouse? It's go. Right? You have to and so that's kind of where we are today. You have to kind of code it. Something like a Dropcam, for example. Dropcam has an Ethernet jack on it. The Ethernet jack is almost entirely dedicated to the configuration. You connect it to your laptop, and then it knows how to communicate across that. And it can set you tell it on your laptop what the SSID is, and then it sends that over that Ethernet jack to the board, the onboard storage. And then you disconnect it, and it goes wireless at that point. You never reconnect the Ethernet jack. It's only for setting the SSID. That's a very realistic problem. The reason I like the IMP specifically is because IMP has what's called a blink up, and they have a little photo receiver in the edge of the chip, or in the circuit. You can put it wherever you want on your design. And you flash on your phone, it flashes a certain series of signals over to that chip, and then it lets you, and that actually tells it what the SSID is and the password is and all that stuff. So that way a consumer can very easily get an app, sync up the SSID, and off they go. The other major one is Spark. Spark is good. The problem I have with Spark's approach is they use a Texas Instruments chip, and the TI chip, it works on wireless. It works on wireless G, on a little sub-protocol that wireless G spec has in it, that lets one device communicate to that device and tell it what to do. In my experience, and working with the Spark core and the specific Texas Instrument chip, is it only works on wireless G. It doesn't work on wireless N. My entire house is just N. I don't even bother with the G people. Right, you're coming over, you're going in, buddy. So the Spark core is a bit of a showstopper for me. The Electric Imp supports N. The wireless stack is written by people who come from Apple. So it's a very solid and robust chip. All right, so there's that. I wanted to try this one other demo here, though. I'm dead again. Gosh darn it. No, that's all right. I don't mind being dead. It's pretty quiet. The flash. Here it comes. Here it comes. Come on, buddy. Work with me. There it goes. So I put this up there again because I wanted to show you. Here comes the big gamble. Big gamble, big gamble. We're created. We're not going. Oh well. I also had earlier when I was testing this earlier today, it was also going out via PubSub, publish subscribe, out to the browsers and the internet as well. So you could actually watch my heart rate as I finish off the presentation if you wanted. Unfortunately, I have failed on that demo. So we will keep moving along and wrapping it up. So if you ain't first, you're last. So where might this be used today? Where is real-time used today? Well, if you've watched a professional sports event, you've seen real-time. You've seen real-time IoT already, right? NASCAR, right? They go around a big circle track usually, and you can see the metrics of the driver. You can see the metrics of the pit. They see everything, right? They see all the metrics of the car and the tire and all that stuff, right? You as a consumer, you see some other piece. And you think about it, those are APIs. Those are APIs designed with real time in mind, not request response. And they're event driven. Something happens in the car, some piece of variable data changes, and poof, that piece of data flies out to the pit, and the pit knows what to do, and they get the bottle of water ready because the guy's electrolytes are running low, and bam. Right, that's event driven. It's an API, just like what you might be familiar with today, but it's a real time API. Finance, the finance world. Nobody, did I go too far back on this one? Dan Aykroyd, Trading Places? No? All right. So the finance world, obviously the finance world has done lots of real time. That's not unusual for them. Medical? No? Going back? Does anybody know who that is?
He's bald now.
Oh, yeah, that's right. He's bald. That's right. That's Howie Mandel from St. Elsewhere. Sweet. All right. Anyway, so medical systems, they use real time today a lot inside of their facilities. And I think IoT is interesting here because what it does is it pulls our medical data to more ourselves, decentralizes it, makes it available, and that's really a really good way to do it. I'm happy with having my medical professional familiar with my medical data in real time as it happens, because if I'm having a heart attack, I want them to do stuff, right? And with this heart rate monitor on me and maybe a watch or something like that, right, with certain indicators, they could certainly figure that out. Why don't they? Well, I think as IoT starts to surface, as we get more comfortable with wearable technology, pedometers and heart rates and GPSs and all this other data, eventually we get to the point where we start feeling really comfortable with all this real-time data. We see it already coming at us, professional sports, finance, and so on. Then we're going to create a momentum. It's going to create a moment in time where IoT becomes very critical, and we'll start to get outside of the firewall, and that creates another interesting problem in its own right. The aviation industry, maybe? All right, it's right. Does anybody speak jive? No? All right, so it blows. This is one of the examples that we went after in the back of our table. It blows my mind that in 2014, as hyper-connected as we are, we lose planes. Like, that blows my mind. Like, this is obviously a place where real-time could come in very handy. The next place to come in real handy is your web application. As you move forward in whatever it is that you're building, whether it be a hobby or whether it be at your jobs, your corporate jobs, or Yelp, or what have you, I would encourage you to stop thinking about designing APIs around REST. Imagine what would happen if the travel industry wasn't built around a request response world, if it was real time. Imagine sitting there, looking at Travelocity and seeing the rooms change as people buy them or say, I'll cancel that. See the seats on the plane change as people, right? We can have that. Why can't we have that? The web supports it. The infrastructure is there to support it. The software is there to support it. So we should think about that as we move forward, because what's going to happen is IoT, right? IoT meets WWW. What's going to happen is IoT is going to do that for us. It's going to make that expectation that things happen in real time. And experience matters, as I was going to put a slide in here that had like a clamshell phone next to the iPhone, right? I mean, that wasn't like, oh, I remember when I was a kid. Like, that was not too long ago that we made that transition, right? Experience matters. And so if I deliver my APIs in real time and you're not, guess who wins? Okay? So when you move forward in your APIs and the things you're doing at work, stop thinking about it. I would encourage you to stop thinking about it. Not all the time. There are places, and not everything's a hammer and everything's a nail, right? We can kind of use gauges if we need to, but I would encourage you to stop thinking about things as XHR and start thinking about them as a WebSocket in real time, push, event-driven, and see what that does. If you have any questions, Twitter's a great place to get me. Of course, I'll be around for a little while as well. I'll put the slides out to Vanessa and Peter, and you can have those as well. I'm happy to answer any questions as well online. That is my IoT meets WWW. Question is why Wi-Fi? Why did I emphasize Wi-Fi and not so much Bluetooth Low Energy? Wi-Fi is just more mature at this point. I have more access to it. Really is what it comes down to. Bluetooth Low Energy is progressing very nicely. It's you find it on more and more chips. Like there's a few different Arduino clones, for example, that ship with Bluetooth Low Energy. So there's certainly a market for that, and certainly that's a great way to go. I like the Wi-Fi. It's just been out. It's more mature, something I'm more familiar with. So it wasn't really a bias. I think they're both great technologies. I just went for Wi-Fi. Yeah. Yes. So the question around if you get enough of this going, do they start kind of colliding or creating a feedback that's unwanted? Maybe. Maybe. I think that could be happen. It could be like true at the application level. It also could be true at the device level. Right? The singularity is near. I mean, you get all these different devices talking to one another. What's gonna, what happens? Or do I really want, as I drive by the street lamp, do I really want the city to sample the data coming off of my car? Yeah, maybe not, right? And those a lot of ethical kind of interesting questions come up, not beyond just the kind of the practical, like does this cause collisions and how are we going to deal with that? But I think there's a lot of ethical potentials as well. But it's happening. IoT is moving forward. We're becoming more connected, and so. And whether or not that's a good thing or a bad thing, right? Is technology outstripping the pace of our law, and all kinds of different issues come into play there, but it is happening. So it'll be interesting to see what the answers are long term. There's a question there, yes.
Yeah. So is there a way to monitor that there's no data loss? Because in hardware that's pretty critical. So do you have an architecture or a way to keep an eye on what data may be lost?
Yeah, that's a great question. So when it comes to I think it was on the speaker. So when it comes to pub sub, one of the great things you get in that environment is things like guaranteed message delivery. Right, so, and then you can and you can say whether or not it gets delivered just for sure just once or for sure multiple times. And so you can start, the architecture is built in there to allow us to deal with whether or not the wire goes down, whether or not the device goes down, whether or not the client goes down, the broker goes down. All those architectural pieces have been solved. Those problems exist and have been solved by pub sub solutions. It's just a matter of getting out the last mile to the web and to the other clients, IoT devices and things like that. So data loss, certainly something to consider, but because of the redundancy and the capabilities provided by a pub sub architecture, far less likely to happen over the long term. Right? You might maybe miss a byte for a second, but then you're going to get it eventually because guaranteed delivery is going to give that for you. So you don't end up losing, ideally, if you architected it well, you don't end up losing anything.
Data stream going.
Well, if you're working in a pub sub environment using the current standards, in those cases what will happen is that data will come across regardless. So the board will come out, the only way architected using modern standards, the only way that this board would stop producing and recording my heart rate is out of range, out of battery, right? Something along those lines. Then it's going to drop. Ain't nothing I can do about that. No standards are going to make that magically happen, except for maybe wireless charging. That would be cool. But outside of that, this guy can deliver data decoupled from everything else as fast as he wants or as slow as he needs to, and the architectures are in place to be able to handle that reliably to make sure the message gets across. Not yet, not widely available yet. Coming though, there are a few web standards around, for example, like game controllers and things like that. So there are some that come that next step. Once you get access to the USB, that's cool. I don't know when that'll hit, but yeah. I have also seen, right, other workarounds, so like desktop shells that wrap web containers, or also on the mobile phone that needs to access the device. So, for example, like your PhoneGap or Cordova wants to access Bluetooth, right? You can wrap that in a native shell to do that kind of stuff. Chrome apps, yes, that's true. Yes, in fact, there's actually a Chrome app for that does the serial for Arduino as well, if I'm not mistaken. There are a couple in-browser Arduino solutions, Most of them use Java as a go-between to get to the USB port. So that is a political question. Yes, net neutrality tramples innovation, in my opinion. As a political statement, I can come off as my own individual, and that would be my, the way these guys are behaving is killing innovation, frankly, from what could happen. That's my answer, and I'm not saying, because I represent a company, right, so I don't want to be all, we can pull out the politics for it. But yes, so yes, shame on them. I know, right? Someone said I'm on the record.
Let's check the heart rate.
So, what a dashboard can become?
Yeah. So right. So when you have all these devices, and right today, so it seems like this creates kind of a dashboardy interface, and I think that's very accurate and astute observation. And frankly, I think what you end up with is an environment where data finds you. And in this case, it's a web UI, right? It might be my iPhone. It might be another device in my house, right? I think that's kind of where I think this trend is kind of generally going. Is rather than me having to seek out information, is the information finds me, or it finds whoever it needs to find if it's coming off of me, perhaps. In the case of the medical industry, for example. And so I think that's where it's going. So I think a dashboard, when we took it like here, yeah. But again, that might be an app on your phone, right? So the medical provider's app, right, senses something, and that data finds you, and it alerts you via the app.
Yeah, this one.
That's right. So you have multiple tiers of different apps with their own notifications. And so I can draw rough parallels here. This is we're looking forward into the future at this point, right? I don't know really what's going to happen, but drawing some parallels from what's happening in the hardware world. Is that there are multiple home automation standards, for example. So what you're starting to see is systems with like 10 of the different standards chips inside of them, right? So that way they're able to manage all the different protocols, and they provide you with one seamless interface, right? And that's their selling point. So in the past, industry has not been very keen at standardizing for data exchange across horizontally. And I don't expect that will change. There may be solutions that come out that offer you dashboards, right? If there are APIs for other things, then I can certainly, well, they may not be going horizontal seamlessly. I might be able to go build an app that goes here, 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 and provides me my dashboard, right? So something like that potentially happening, which is effectively what's kind of happening in the home automation space as it kind of matures into this IoT space. So I think, I think that kind of, I don't want to share my data with you. We'll see if that changes though, because it's interesting. Who is it? I think it's Quickset that has a door lock that's IoT enabled. And in order to access that, you have to go through their website, right? So that's, well, what if my back door is a different brand, right? I'm going to go to a different website to control my house. That's ridiculous. But on the flip side, there's a startup called Lockatron. And Lockatron actually goes the other way. They're like, hey, we're open source all the way, right? And that's their big competitive advantage, right? And you can get in there and you can hack it and you can change it, and we share the protocols, and that's that, and you're off to the races. So we may end up going that way. We'll see. We'll see.
There.
Yeah, I think.
Comment.
Yeah, it's kind of like so I think it's a very like kind of a hub spoke kind of model. I totally, yeah. I think that would be a predominant model. I don't think it will be the only model. I think it will be a predominant model. There are no, and I think it's beyond. I think that goes beyond kind of the idea of data sharing. I think there are also technical limitations what we're trying to deal with as well, right? Right, Wi-Fi. It's hard enough for me to get this guy on Wi-Fi. If I was going Bluetooth with my phone, that'd be a whole different story, right? So that solves some connectivity problems, and then of course wireless is still very hungry from a power perspective. Maybe wireless charging solves that problem. Maybe there's other battery technologies that emerge. Maybe I just go Bluetooth low energy, put a coin battery in there, and not have to worry about it for a year, right? Especially on a golf swing, like I might be able to go for several years on a single battery, right? That's awesome. So yeah, I think that will be a predominant model. I don't think it'll be the only model, actually. I do think it'll be the predominant model if we think about it as individuals and as people in the space. But I think at some level, right? You get a place where it becomes a broader exchange of data as well, right? So where, for better or for worse, government officials say, hey, GM, we would like to integrate this with your cars, and so that we can track things going down the highway and where they're at, and we can control traffic more effectively then, right? And so then it becomes this kind of mesh, and I think that's the other predominant model that will mature. So, good question. Peter.
All right. I think that was it. Thank you.
That was it.